Welcome to Atlas Copco Gas and Process IndustReal podcast. My name is Candice Wilson, and today we're chatting to Daniel Patrick, a hydrogen market expert for Atlas Copco Gas and Process. Daniel, thanks so much for joining us.
Thanks, Candice. I'm happy to be here.
So for our audience, real quick, you look after the hydrogen market for Atlas Copco. Could you give us a little bit of an introduction on your journey and how you got here?
Sure. Yeah, I guess I'll maybe start back at the very beginning. I was when I was a kid, I knew I wanted to be a mechanical engineer. I really loved any type of machine and studying machines. My dad always told me the best way to understand a machine is to take it apart and inspect it. But I didn't always remember how to put it together, so I certainly had some lessons learned growing up. And then moving forward in high school is really when my passion for renewable energy came about, because I took an environmental science class. And in that class, I learned about the effects of greenhouse gases and global warming. And in that same semester, I actually took a technology class where I learned about fuel cell vehicles, hydrogen as a low carbon fuel and a clean fuel. So that really sparked my interest in low carbon fuels and decarbonization. So I've been lucky for the past 10 years to be able to follow this passion with Atlas Copco to support the hydrogen industry. And as you mentioned, that's what my role is now. I'm covering the hydrogen market for the turbo machinery product line.
Thanks so much for the introduction. Your passion for hydrogen and a cleaner future. Tell us a little bit where hydrogen fits into this clean energy mix. Do you think it's going to help us get to net zero?
Yeah, it's a tough question, an important question for us to address. I'm certainly optimistic about hydrogen. It's an important tool in our toolbox, but it isn't a fix-all for our challenges ahead. We'll need to utilize many different decarbonization efforts. One of the other opportunities that we want to maybe pursue first is electrification. And one of our earlier industrial podcasts, actually, we covered that focus on heat pumps. So if you haven't seen that, I invite you to go check it out. But there's plenty of applications that you can't electrify, and that's really where hydrogen shines. These are applications like heavy-duty trucking, heavy-duty transportation in general, so that could be airplanes, boats, trucks, long-duration energy storage, or cement or steel, where you really need to burn a fuel at a high temperature. So that's where hydrogen can really shine.
So one of the main challenges that I hear with regards to hydrogen is the storage and transportation. What are your thoughts here? Do you think these challenges can be addressed?
Yeah, transporting hydrogen is difficult just because it takes up so much space. So one way to address that is to liquefy that hydrogen and reduce that volume. So when compared to gaseous hydrogen, liquid hydrogen has some nice advantages for transporting to sites, or even for storing that hydrogen at site to reduce the size of the storage at site. And to give you some context of that volume reduction, one liquid hydrogen tanker truck can carry the same amount of hydrogen as 8 gaseous hydrogen tanker trucks. So pretty significant.
Wow, that is significant. So liquid hydrogen is the most effective way of transportation, specifically to the end user location.
Yes, absolutely. That's certainly one of the main drivers to liquefy hydrogen. But there's one additional application for liquid hydrogen besides just transporting it to the site. It's actually for onboard storage for these vehicles that are using this carbon-free fuel. So applications in long-haul trucking or long-distance flights really will utilize liquid hydrogen just to get longer range out of these vehicles. And in the future, I see liquid hydrogen, this market, looking a lot like the LNG industry. And we have some great experience in the LNG industry with our turbo machinery, and we can certainly apply that experience from the LNG industry to liquid hydrogen on the refrigeration side and on the boil-off gas handling. Actually, I wanted to mention we were the very first to provide a liquid hydrogen boil-off gas compressor for a ship carrying liquid hydrogen. So I thought that was pretty cool.
That is pretty cool. So Okay, so we know that the smart choice is liquid hydrogen when it comes to transportation. But now, how do we liquefy that hydrogen? I believe it needs to be at really cold temperatures.
Oh yeah, super cold. So hydrogen liquefies at minus 253 degrees Celsius, or for us Americans, that's minus 423 degrees Fahrenheit. So quite cold.
It is very, very cold. So speaking of cold, how do we get those gases to such cold temperatures?
Yeah, that's really where the turbo machinery comes in. So essentially when we liquefy, we're using an industrial refrigeration process. So compression and expansion to provide that refrigeration. And this supercools the hydrogen to these cryogenic temperatures and liquefies it. It's actually quite similar to other cryogenic processes like air separation or natural gas liquefaction, LNG, just at a colder temperature. So NASA has been using liquid hydrogen for rocket fuel since the 1960s, so the hydrogen liquefaction process isn't new, it's been around for decades.
That's super interesting. So if it's been around for decades and we've been liquefying hydrogen, what's so new now in the hydrogen market and what's changed?
Yeah, that's a good question. So these early hydrogen liquefiers that NASA used, they were relatively small, and the cost of the hydrogen wasn't super important. NASA has a huge budget, as we know, but now to enable hydrogen for the masses and to reach cost parity with diesel really is the goal. The cost really needs to come down for hydrogen delivered to the fuel station. So the focus has shifted from small liquefiers to large-scale liquefiers. Increase that scale so we can get economies of scale and really drive down the cost of hydrogen.
And how does this capacity affect the turbo machinery design?
Yeah, turbo machinery actually likes higher flows, and we get better performance from higher flow, higher capacity applications. So this is a good thing. Small scale expansion turbines that they've used in these small liquefiers, they use gas bearings very fast. They work quite well for the small liquefiers, but they have limitations in how large they can go. So these offered an oil-free solution. So this was one of the challenges that needed to be addressed. So one of the innovations we've made at Atlas Copco is to offer magnetic bearing turbo expanders, which allows high capacity refrigeration in an oil-free configuration still, and it also enables energy recovery from that turbine, this turbo expander. So this is certainly something that sets us apart. We're the first to offer magnetic bearings in hydrogen liquefaction. This also means we can do the cooling duty in less machines. That improves reliability, reduces your maintenance, all sorts of good things for our customers and end users. And we have hundreds of magnetic bearing machines running in hydrogen-rich applications, so plenty of experience. This isn't new for us.
So Daniel, to summarize what we've discussed today, we know that hydrogen offers great promise in terms of decarbonization. Mm-hmm. We know that it assists with increasing the density of our fuel, so allowing more efficient transportation, and also assists with the heavy-duty vehicles and transportation there. Mm-hmm. So I think for sure I can say that our turbo machinery really assists with the liquefaction process, allowing more efficiency for our customers.
Exactly. Yeah, that's a perfect summary. Thank you, Candice. I think we're going to be seeing a lot more liquid hydrogen here in the near future.
Yeah, me too, and I'm excited. I'm excited to see it and read about it.
Me too.
So thank you very much for joining us today, Daniel.
Thanks for having me.
And thank you very much for viewing us today. Stay tuned for our next episode where we deep dive into new energy.